All right, starting binomial probability distributions. This should be a pretty quick PowerPoint. And I'll also at the end of the PowerPoint transition over to StatCrunch and show you the easy way to do stuff. So in this video, I'm going to teach you how to calculate probabilities from a binomial distribution, talk a little bit more about binomial distributions in general, and then we'll use a binomial distribution to solve business problems. So remember, discrete means that we're encountering something that is countable, like the number of times that you check maybe Instagram per day. And continuous is something that you measure. That could be your height, your weight, etc. So types of variables, discrete variables, we typically look at a graph, examine a graph that looks more like a bar chart, so the bars do not touch. For a continuous variable, we'll get into that in the next couple of videos. We actually look at these smoothed out distributions, so more about that later. So the probability distributions we'll study, different discrete probability distributions are binomial and Poisson. We will only study binomial in this class just due to time constraints. And we'll study the normal distribution for the continuous probability distribution. Now, binomial, remember, the prefix bi means two. So we start out with a fixed number of observations. It could be the number of tosses of a coin, light bulbs taken from a warehouse, whatever we are investigating. Each observation must be classified into a mutually exclusive and collectively exhaustive category. In other words, you can't have an observation that falls into each of the two categories. So if we flip a coin, it's either going to be head or tail. It can't be head and tails. And if we have measuring a light bulb as either defective or not defective, hey, the light bulb either comes on or it doesn't, right? So it's defective or it isn't. So getting into a little bit of notation, we use pi, not 3.14, not dealing with the circumference of a circle. Geometric interpretation, but just using the Greek letter pi to represent the probability of the event occurring. And of course, since we only have two outcomes, this or that, the probability of the event not occurring is just 1 minus pi. Because remember, in a discrete probability distribution table, the sum of the probabilities has to be equal to 1. So again, just stressing the importance, the value on any observation is independent of the value of another observation. Now, what do I mean by that? What I mean by that is if I flip a head, I'm sorry, if I flip a coin and I get a head, that has absolutely no impact on what I'm going to get the second time that I flip the coin. So we say that those things are independent because they are not related. So possible applications for a binomial distribution. I think I've gone over this in a previous video, but labeling items as defective or acceptable, and bidding contracts that you're either going to get or you're not going to get. So again, binomial, the prefix bi means two. It means that it has to come, the result has to fall into either this or that. The binomial distribution formula is ugly. Now, don't give up on me yet, all right? Stick with me. I'm going to teach you a way in StatCrunch that bypasses all that stuff. That formula up there is music to my ears. I've just always enjoyed that kind of stuff, right? A lot of people don't and would flip out. But let me tell you behind the scenes what's happening here. So we're all the things, the statement to the left of the equal sign just says that we're calculating the probability that X, our random variable, is equal to some value given N and pi. Now again, N is the fixed number of observations and pi is the probability of getting the event that we are measuring. So A few things. If we look at the example to the right in the box, it says flip a coin 4 times. So we're going to let X equal the number of heads. So n is equal to 4 because, for obvious reason, we're flipping the coin 4 times. Pi is equal to 0.5 because if it's a fair coin, we have equal likelihood of getting a head or a tail. 1 minus pi is equal to 0.5, and X can take on the measure of either 0, 1, 2, 3, or 4. Because again, if we flip the coin 4 times, we could get no heads, we could get 1 head, 2, 3, or 4 for obvious reasons. Again, don't get too upset about that crazy formula with all those factorial signs. I'm going to teach you a much easier way using StatCrunch. So the binomial distribution, if we were going to work this problem using the formula, so suppose the probability of an invoice being paid on late, is 0.90. What's the probability of one late invoice payment in a group of 4 invoices? Well, because the probability is set at 0.10, pi is going to be 0.10. N is equal to 4 because we're examining 4 invoices. X is equal to 1 because that's what we're calculating the probability of. So somewhere on a sheet of paper, I want you to write this down. I'm going to show you how this is performed, completed much easier in StatCrunch. As I say, StatCrunch can and should be used to calculate binomial probabilities. Another thing that we run into with binomial distribution characteristics is we can calculate the mean, variance, and standard deviation. It turns out that these calculations are very, very easy to make. The mean is found by just taking n times pi, and the variance is found by just taking n times pi times 1 minus pi. And then if I take the square root of the variance, of course, I get the standard deviation. So play along with me here. Grab your calculator. If n is equal to 5 and pi is equal to 0.6, then 5 times 0.6 is equal to 3. So the mean of the distribution would be 3. The variance would just be 5 times 0.6, then 1 minus 0.6, which is 0.4. So if I take, I'm just double checking on my calculator to make sure I didn't do something goofy. So the variance would be equal to 1.2. If I take the square root of 1.2, then I get 1.095. So again, the mean, variance, and standard deviation are easy to find. Now let's exit out of this and let me bring up StatCrunch, do a little window dressing here, if you will. And let's go to this problem that looked very, very difficult to solve. That's not the one I want. That's not the one I want. Which one? Here we go. This is the one. So suppose the probability of an invoice payment being late is 0.10. So we said earlier that tells us that pi is going to be equal to 0.10. What is the probability of 1 late? That tells me that my X is 1. And out of a group of 4 invoices, that tells me that n is equal to 4. So really cool stuff, really easy to do over here. Let's just go to Stat and go to Calculator and go to Binomial, as you would expect. Let's enter the value for n. So we know that's going to be equal to 4. Let's enter the value for p. Now, the p there stands for the pi, okay? So whatever our probability is, in this case, it's 0.10. And then I can do compute, and I'll get the graph of the probability distribution. You can see that this is right tail, okay? So what I want the probability that X is equal to 1. And you can see I get 0.2916, which is the same thing they get using this crazy formula. Okay, so again, binomial distribution problems are easy to do in StatCrunch, and they don't require a lot of uh, manipulation of this formula. All right, gang, that's all I got. Take care.